section 1.5, the inverse function. This is your homework for tonight, or this week at least, or weekend. We're going to be talking about the inverse function, what it means to be an inverse function, how to find it, and what the graph looks like. So, inverse function is, let's see if I can get this thing going. There we go. It's represented by f of negative 1 of x. And we talked about how functions are input, we put input in, which is x, the output, which is f of x. What happens with an inverse function is we go backwards. We go through the output, and then we get the input. So we switch it around. So what does it mean to be an inverse function? I don't know what that is. Cancel. Whatever. An inverse function is a function that undoes the original function. So if we have a specific function that goes from one spot to another, calling it f of x, what will happen is the inverse function will take it back to where it belongs. And we get a result of the identity function. So the inverse function is a composite of the original function resulting in the identity function. The identity function is f of x equals x. So we have f of the inverse function equals x, as well as the inverse function of f of x equals x. And we'll be talking about how what that means, and that means it is 1-to-1. But we'll get to that in a jiff. If f of x and g of x are functions, then f of g of x equals x. Therefore, what the devil? Don't show this message again. Thank you. Then g of x is the inverse of f of x. You can pause it at any time and do whatever you want. There will be a moment where I'll ask you to pause, and you can go ahead and pause it. Okay, so here's an example of a function as well as another function, and we need to show that these are inverses of one another. So, i.e., f of g of x equals x, and g of f of x equals x. So what we do is we take the value, so we'll go ahead and do f of g of x first, right here, and we're going to take this whole chunk here and put it into our, I think I have a little pen tool. Okay, there we go. This goes directly into here, and so we plug it into the function itself, the whole entire thing, which looks like this. So now we have this big thing here. Probably should put some parentheses around it, and the cube root cubed is going to undo itself. So we now have 2 times x plus 1 over 2 minus 1. These happen to cancel out. And now we're left with x plus 1 minus 1, which turns out to be f of x equals x. So this equation right here is proven to be that. Therefore, we have an inverse function. So g is the inverse of f of x. We do need to double check this one right here, but you can do that one on yourself. It's the same type of thing. We're just going to plug in this whole thing directly into our x value here. Okay? And what happens is that we get our 1's cancel out, our 2's cancel out, and we're left with the cube root of x cubed, and the cube root of x cubed is just x. So it works out. So let's take a look at another one. F of x equals 5 over x minus 2. And we want to decide which function is the inverse of f of x? Is it h of x, which is x minus 2 over 5, or is it g of x, which is 5 over x plus 2? So how about you try it? Go ahead and pause the video and work it out for yourself, and then afterwards I will give you the answer. So we're taking, just to clarify, we're going to take each one of these and plug it in for x, as well as taking this and plugging it in for the x of h. So you would want to do h of f of x. I'll be getting a stylus, so this looks a lot better. As well as doing the f of h of x. And then you need to do the same thing for g to figure out what that is. So go ahead and pause the video and work on that. Alright, so you pause the video and you're back to where you get it. Let me see if I can erase. Is there an erase tool here? I don't know if there's an erase. Here's an arrow tool. Maybe I can just click. Oh, there we go. There's our answer. Go back to the pen. I like it. Okay, so we have our answer is g of x. The graphs. What do the graphs of these functions look like? Well, the graph of the inverse function as a relation to the graph of the other function reflects over our identity function, y equals x. So remember, y equals x goes right down kind of the center of everything. So here's our graph. It goes right down the center right here. So if we have some f of x, oh, there's our, sorry, here's our y equals x. So if we have one value over here, the same thing is going to be on the other side. So it mirrors itself over our identity function. So we have our identity function y equals x. We have our original function f of x, and the reflection is going to be over there. Y, or f negative 1 of x, our inverse function. I also want to note that at any point here, suppose we have a point here, this point, you know, is what, negative 5, negative 2. Our inverse function is going to be negative 2, negative 5. So it switches the values. So over we have negative 2, comma, negative 5. That's right there. Not drawn perfectly, but you get the idea. So our AB, the inverse of that point is BA. And that's at every single point. That should be right about right there. Moving on, let's graph what we did before. So we had f of x equals 2x to the third minus 1, and g of x equals the cube root of x plus 1 divided by 2. Alright, so let's go ahead and graph those. We have our first function, 2x cubed minus 1. It's right there. That's f of x. We have our identity, and g of x, we did show that it was an inverse, so it should reflect over the values. So we have our inverse function. Once again, maybe a little bit closer here, but it reflects exactly every point to every point. If we were to look at this on a table, what we see is that our columns are flipped. So we have our x is negative 2, negative 1, 0, 1, and 2. Over here, our y values are negative 2, negative 1, 0, 1, and 2. So we just take these columns and flip them, and we get our inverse function, which goes along with what we said in the last slide, which is AB turns out to be BA for the inverse. Alright, so how do we know a function has an inverse? Because not all functions have an inverse. Well, a function is one-to-one. I think I'm a little bit off here. I'm going to go ahead and put the whole slide in. So one-to-one, that every function does not have an inverse. So I'm reading from right here. So for example, we have f of x equals x squared. F of x equals x squared. The inverse is not a function. So we have x, plug in values for x, like -2, -1, 0, 1, and 2. Our y values, or our f of x, is 4, 1, 0, 1, and 2. Now, if we look at the other table, it flips. Remember, we have a, this is a and b. Therefore, this must be b and a to have an inverse. Well, what we see is that there are two values for x, and therefore those have two answers, which is -2 and +2. And we've studied in the very first section, 1.1, that that is not a function. Okay, so I'm over here where the star is. A function is considered one-to-one if for every a and b in its domain, f of a equals f of b. Implies that a equals b. Okay, so it might be confusing, but when you actually test it out, you'll understand what I'm talking about, which it's not on the next slide, but it's on the following slide. A function is an inverse, IFF, which I'm going to be using as if and only if it is one-to-one. So a function can only be an inverse or have an inverse if it is one-to-one. So we have to figure out, well, how is it one-to-one? Well, we use the horizontal line test. We use the vertical line test to test if something is a function. We use the horizontal line test to test if it is a one-to-one function. So here's some examples of what I'm talking about. Suppose we have this function right here. It passes the vertical line test, so we know that it is a function. However, if we do the horizontal line test, we can see, oh, well, this function is not one-to-one, therefore it does not have an inverse. If we have another function like this, which passes the vertical line test, it also passes the horizontal line test. Therefore, this function is one-to-one. So we can say the first one fails, so it is not one-to-one and does not have an inverse. And the second one passes. So it is one-to-one and does have an inverse. How do we do this algebraically? Well, let's find out. If f of x equals x, or square root of x outside plus 1, let's find out if that's one-to-one. So is it one-to-one, and therefore does it have an inverse? Well, we take f of a and equal it to f of b. So we plug in the value of a here into our equation and put it on one side, and plug the value of b in here and plug it on the other side. So we end up getting the square root of a plus 1 equals the square root of b plus 1. And we have to see if this implies that a equals b. So let's do some algebra. We're going to subtract 1 on both sides. So these are going to cancel out, and therefore these cancel out. And we end up getting the square root of a equals the square root of b. So our next thing we would do is square both sides. And if we square both sides, those cancel out, and we get a equals b. And hey, this is what we're looking for. So we start out with this, and we end up with our answer, a equals b. Therefore, f of a equals f of b implies that a equals b. So you'll be having to do that on your homework assignment. There you go. You can pause the video if you want and take notes or whatnot. Okay, finding the inverse of a function algebraically. Period. Oops. Alright, so this is the important thing. You'll be doing this a few times on your homework assignment. Here's the steps you need to follow. First, we need to determine if the function is one-to-one. We could use the horizontal line test, so you can graph the functions and see if they pass the horizontal line test. Or you can see what we did on the previous slide. You can go ahead and do that and see if f of a equals f of b implies a equals b. Secondly, we're going to change our f of x to y. Third, we're going to change every value that we have in our equation of y, that is a y, turn it into an x, and every value in our equation that is an x, turn it into a y. And examples really prove the best way to show this. But we're going to just change them around, switch the terms. And then we need to solve for y again. And after we solve for y, we replace y with our f negative 1 of x, our inverse function. And then, of course, we need to check that f of the inverse function of x equals x, and the inverse function of f of x equals x. Let's try it out. Here we go. All right. I'm going to use a little sanitizer. And let's try to find the inverse of f of x equals 5 minus 3x divided by 2. First off, I'm going to do it algebraically. We plug in f of a and set it equal to f of b. You can do it yourself, but they do actually equal each other. That implies that. So, let's go ahead and go through our steps. First off, we're going to change it to a y value. And then we are going to change our values here. So we turn our y into an x and our x into a y. And now we need to solve for y. So we multiply both sides by 2. We subtract 5. And then we're going to go ahead and divide by negative 3. And what happens? We get 5 minus 2x divided by 3. That step, I kind of did a whole bunch of steps at once. So we did 2x, and I have negative 5 plus that equals negative 3y. Divide by negative 3. Divide by negative 3. And I went ahead and said, okay, that's the same thing as 5 minus 2x over 3, because these cancel out. So we get our value here. And sure enough, that is our inverse function. Okay? So at that point, you would want to check your work. You take your inverse function and plug it into our x value up here, and then vice versa, take this and plug it in right here, and it should work out. If it is an inverse, yes. Alright, I hope that makes sense. Remember, you come to class with homework questions. You can try finding the inverse of these following things. First off, we have f of x equals 5x minus 7. So try to find that, and I will give you the answer in 3, 2, so pause the video if you want to not see the answer, 1, there it is. And then go ahead and try f of x equals the square root of 2x minus 3. Pause the video for this one and try it out. I'll give you the answer in 3, 2, 2.5, 2 3/4, 2 2/8, 1 and 1, I don't know. There you go. So our answer turns out to be the inverse function negative 1 of x equals x squared plus 3 over 2, when x is greater than 0, of course, because we need information right there. Alright, so hopefully that clears this up. If there's some confusion right here, don't worry about the domain too much just yet. We'll cover that in class. So guess what's next? Your homework. There it is. It's kind of, I tried to tone it down a little bit, so I had selected problems. These two are a little bit difficult, but I'd like you to try them. And so I tried to cut down your homework assignment. You will be also having a proof pass on Tuesday. So you're going to come in with homework questions, work on your homework, whatnot, and then the other half of the class I will give you your proof pass, and you can work on that in class as well. So thank you for watching the video. Hopefully that was informative, and have a good rest of your weekend. Try not to go crazy with too much homework. I tried to not give you so much homework. And if you're spending more than an hour on a homework assignment, there was one homework assignment that's kind of big. I understand that might take a little bit longer than an hour, but this shouldn't take more than, I would say, at the most, an hour and a half. So, I mean, come into class, and if you have any trouble on any problem, just skip it right away. So I would say for this homework, you shouldn't spend more than 30 minutes working on it. 30 minutes to an hour at home. Okie doke. Drew some nasty pictures. Adios, class of mine. I will text you in about 10 minutes when this is uploaded. Goodbye.